Welcome to another video. We are given a simultaneous equation given that x plus y is equals to 3 and x multiplied by y is equals to 9. So do you realize that we're gonna get complex solutions for x and y? So I'm going to take you through step by step up to the final solution. If you're watching for the first time, please remember to subscribe. For the returning viewers, feel welcome and always turn your notification on. So straight away on to the solution. So I'm going to call this equation 1, while this one I'm going to call it equation 2. So from equation 1, I know that x plus y is equals to 3. From here, I can let x to be equals to 3 minus y. So that substituting this value of x in equation 2, then wherever I have x, I'll substitute 3 minus y. So that becomes 3 minus y in bracket multiplied by y is equals to 9. Opening the bracket, I'm gonna have 3y minus y squared is now equals to 9. Then I can rewrite it as a quadratic equation. So arranging this to form a quadratic equation, I'm gonna start with the positive y. So I've taken this y squared on the other side, and this taking it gonna be negative 3y, of course, plus 9, then is equals to 0. So then from there, I want to identify the coefficients of y squared is 1. The coefficient of y, I'm going to call it b, that is negative 3. And the constant term is 9. Substituting this and working it out using the quadratic formula, then y is equals to negative of b, so that is negative 3, plus or minus the square root of b squared. Of course, that becomes negative of 3 squared minus 4 times a times c, everything divided by 2a. So that is 2 times a, or 2 times 1. So this, simplifying it, I'll have y now is equals to negative 3 times 3, that is of course positive 3, negative times negative 3, that is positive 3, plus or minus the square root of negative 3 squared, that is 9, minus 4 times 9, that is 36, divided by 2 times a, that is 2. From there, simplifying further, y becomes 3 plus or minus square root of 9 minus 36. I want to get negative 27 divided by 2. This negative 27 can be written in terms of its factors, so that I simplify it as y is equals to 3 plus or minus, this is equivalent to root 9 multiplied by root 3 and then multiplied by root negative of 1 all over 2. I know root 9 is giving me 3, so that, and root negative 1, I want to represent it as I, since it is an imaginary or a complex number, so that y, final y becomes 3 plus or minus, this is 3, root 3 I divided by 2, So since this is positive or minus, it is either the first y is a positive 3 plus 3 root 3i divided by 2, or the second y will be a negative, so 3 minus 3 root 3i divided by 2. So of course you have managed to compute the value of y's. Kindly, if you have watched up to this particular point, remember to subscribe, share, leave a comment, and turn your notifications on. So for me to get the value of x, I shall substitute these values in my equation 1 so that I have x plus y is equals to 3, and wherever I have y, I want to substitute the positive part, the all of this, so that I have x, of course, plus 3 root, so this is bracket, root 3i divided by 2, giving me positive 3. So for me to remain with the value of x, I want to carry all this and take it to the other side of the equation, so that I end up with x now becomes 3 minus 3 plus 3 to the root 3i divided by 2, and simplifying this as a single fraction, I'm gonna have 2, that is 2 goes there, the denominator is just 2, so 2 goes there, 2 times 3, that is 6, minus 3 plus 3 to the root 3i, which this can be re-expanded as, opening the bracket, x becomes 6 minus 3 to the root 3i, everything divided by 2, and there goes that for y1 is equals to this, then my x2, the corresponding x1, will be equals to, that becomes 3 minus 3 root 3i over 2. So you realize that both the corresponding value of x is a complex number, then the corresponding value of x and value of y are both complex numbers. Let's try for the second value. For y2 is equals to 3 minus 3 root 3i over 2. Then of course substituting in x plus y is equals to 3, I want to get, so wherever I have x, I shall substitute, wherever I have y, I shall substitute the all of this, so that now my x becomes plus, in bracket, 3 minus 3 root 3i over 2 is giving me 3. And then taking this on the other side, this is positive, and when I take it on the other side, x now becomes 3 minus 3 root 3i over 2. Opening the bracket and simplifying, the second value of x2 for the corresponding y2 will become, opening this becomes positive, and is 6, that is 6 minus 3 plus 3 root 3i over 2. So that means that the final value of x2, which is corresponds to this y2, will be equals to 3, of course, plus 3 root 3i divided by 2. And that brings us to the final solution to this particular Math Olympiad equation. I hope you've learned. Please kindly comment with an alternative approach leave a reply and also turn your notifications on. Let's meet in the next video. Goodbye for now.